Hello everyone, I am Aftab Alam, Maths faculty in Motion Education. So today we are going to discuss here sets theory. First of all, I will discuss here what is called set, then method to represent sets, and finally I will discuss types of sets. Okay, so I am going to discuss what is called sets. What is called sets? Actually, a set is a collection of well-defined object. A set is a collection of well-defined object. Okay, now see this here. A set is a collection of well-defined object. Well-defined means not misguided. Well-defined means not misguided. Means it should be very clear that in which sense we are going to talk here. Okay, now for example, if I am taking here example, a collection of beautiful girls in the class. This beautiful word is misguiding us. We are not clear here in which sense we are going to talk here. Okay, means this beautiful can be in long hair sense, or it can be in like fair skin sense, or it can be in brain sense also. Okay, so it is not clear. Okay, now so actually after this, what is the next point? Next point is sets are always denoted by capital letters. For example, like capital A, capital B, and capital C. Okay, and so on. Now see this here. Next point is and its elements or you can say object, or one more name is there, you can say members are denoted by a small letter, okay, and then enclosed by curly bracket. See this here. A set is a collection of well-defined object. Okay, well-defined means not misguided. It should be very clear that in which sense we are talking here. Okay. So next point is sets are always denoted by capital letters. Means in this way, capital A, capital B, capital C. Okay, and its elements, or you can say object, or you can say members also, are denoted by a small letters. Okay, and then enclosed by curly bracket. For example, I am taking set A is there, okay, and elements of this is A, B, C. Now see this here. This is a set because this is denoted by capital A, so this is a set A, and inside this how many elements are there? 3 elements: a small a, small b, a small c. And we know that objects, or you can say elements, or you can say members, are denoted by small letters. Okay, so this A, B, C are the elements of this set A. So can I say in this way, this A belongs to this set A, this small b belongs to set A, okay, and this small c belongs to set A, okay, and D does not belong to set A. What is the meaning of this? Means actually there is no any element which is present in this here. Means D is not present here. Okay, so we can say that D does not belong to set A. Okay, so I hope you are getting this. Next example is set A equals set of all vowels of English alphabet. So what is the meaning of this? See this here. Set A is there. What is the name of set? A. Okay, and set of all the vowels of English alphabet means we know that English alphabet A, E, I, O, U. Okay, so what is this? These are the elements here. These are elements of this set A, or you can say members, or you can say objects of set A. Okay, or you can say in this way A belongs to set A, E belongs to set A, I belongs to set A, and E O belongs to set A, and U belongs to set A. Why? Because these are the elements of set A. Okay, so this is the notation of set and its elements. Okay, now we are going to start method to represent sets. Method to represent sets. Method to represent sets. Method to represent sets. Okay, so mainly there are two method to represent sets are there. So first is roster form, or you can say tabular form, Okay, now see this here, what is called roster form or tabular form. In this method a set is described by a listing elements. In this method a set is described by a listing elements, separated by commas, and then enclosed by curly bracket. Now see this here, what is called roster form or tabular form. In this method a set is described by listing elements, or separated by commas, okay, and then enclosed by curly bracket. Okay, so I am going to take example here. A set of all natural number, the set of all natural number, the set of all natural number which divide 42 is, which divides 42 is. Okay, now see this here. For example, I am taking the set of all natural number which divide 42 is. So it's very simple. This 42 is divisible by 1. Suppose I am going to consider set name A here I am giving. Okay, so this 42 is divisible by 1. Okay, this 42 is divisible by 2, 3, okay, 6, 7, 14 and 21 and 42. Okay, so these are the elements, or you can say object, or you can say members of this set A. Why? Because this is the question, the set of all natural number which divide 42. So 42 is divisible by 1, 2, 3, 6, 7, 14 and 21 and 42. Okay, so these are the elements of this. So this is called roster form. Roster form means numerical values will be there, so we can say this is roster form. Okay, now one important note is there, I am going to write here. One important note is there in roster form. One important note is there. See this here. Note: we must not repeat any element. We must not repeat any element in roster form. So see this, what is the meaning of this? We must not repeat any element in roster form. Okay, so I am going to explain with example here. See this. Suppose a set is there like A and Anand, A and D. Okay, A and D. So what will be this value? So I am going to consider a set A. Okay, now see this here. How to write? We must not repeat any element in roster form. So how to write in form of set? See this here. Here actually A is repeating. How many times? This A is repeating 2 times. So we will count only 1 time. A. This N is repeating 2 times. So we will count only 1 time. N. okay, and D is only single time, so D. Means actually what is the meaning of this in roster form? This is the rule of roster form in means in case of roster form, if a if a numbers or if a words or if a letters are repeating 100 times, we will count only single time. Okay, see here A is repeating 2 times, we are counting only 1 time. N is repeating 2 times, we are counting only 1 time. This is the rule of roster form. Now we are going to discuss set builder form, or you can say property method. Now see this here, second method. Second method, set builder form, or you can say property method. 2. Set builder form, or you can say property method. Property method. Now see this. What is called set builder and property? In this method, we write down property, or rule. In this method we write down property or rule in which which give us all the elements of set. Okay, now see this here. What is the meaning of this? Actually in this method we write down a property or rule which give us all the elements of set. That's why it is called property method, or you can say set builder form. For example, I am going to explain here. Suppose here set A is there, okay, x such that px, okay, x such that px. What is the meaning of this? This px is denoted by here property. Px is property. Here px is property by which x belongs to A and colon. This colon means such that. Colon means such that. Now see this here. What is the meaning? X belongs to set A. This is the element such that px is property. Px is the property by which x belongs to A and colon means such that. Now I am going to take example. With the example you can understand easily. See this here. A set A equals, it is given suppose 1, suppose it is given 2, 4, 6, 8, in this way it is going. Now can be represented in builder form. Now see this here. A set A is given 2, 4, 6, 8 and so on, can be represented in builder form. So see this, how can we represent in builder form? It's very simple. If you observe, you can say this is a 2, 4, 6 means multiple of 2. Okay, so can I write in this way? Set A equals, okay, x such that px, okay, px comma x equals to 2n. Why 2n? Because it is the multiple of 2, 4, 6, 8 in this way. So multiple of 2, that's why I am writing here 2n. But if you put n equals to 1, so you will get 2. If you put n equals to 2, then 2 into 2, 4. If you put n equals to 3, then you will get 6. In this way 4 and so on it is going. Okay, now see this here. And one condition is there, n belongs to natural number. Why natural number? Because actually this is starting from 1. If you put 1, so it will become 2. If you put n equals to 2, then you will get 4, and it is going up to infinite. So we can say n belongs to natural number. This condition is very, very, very important to write. Why? Because if you put natural number start from natural, what is called natural number? Natural number is all counting number is called natural number. If you put n equals to 1, it will start from 1. So if you put n equals to 1, then you will get this 2, 3, 4 in this way it is going. Next example is, what is the next example? See this here. Next example, set B is given 1, 5, 1, 4, 9, 16 and so on. Okay, write in set builder form. Write in set builder form. Now see this here. We need to write, this is given in, first of all we need to identify, actually this is given in roster form. Why? Numerical values are there, we are not using any property, so this is numerical value is given, it means this is in roster form. Okay, now we need to convert in set builder form, so it's very simple. See this here. First we need to identify pattern here. 1, 4, 9, it means this is the square of 1 square 1, 2 square 4, 3 square 9 and 4 square 16 and so on, it is going. Okay, now see this here. So what we will write in this way, x such that p of x. Okay, and condition is that x equals to n square and n belongs to natural number. Why n belongs to natural number? Again, because it is starting from 1. If you put n equals to 1, then you will get natural number start from 1. So if you put 1, so 1 square 1. If you put 2, so 2 square 4, 3 square 9, 4 square 16, and it is going. So that's why n belongs to natural number. Okay, so I hope you are getting this, means how we are writing in like set builder form or property method, or we can convert in roster form. Okay, so now we are going to discuss lots of example which is related to roster form or set builder form. Okay, so our first example is express set B, x square such that x less than 4 and x belongs to whole number. So we know that first of all we will try to understand here, x belongs to whole number. Natural number including 0 is called whole number, means it will start from 0. Okay, and condition is given x less than 4. So x less than 4 means it can be 3, 2, 1, 0 and minus 1. These are all the things so we can write, but actually condition is given x belongs to whole number, means it will start from 0 only. So 0, 1, 2, 3. Now this one is actually set B. Okay, now what we have to do, a square of these numbers, a square x less than 4 and a square of this, because this is given in set builder form, or you can say property method, set builder form. Okay, and we need to convert in roster form. We know that in roster form our answer will be always numerical values. Now see this here. So a square of 0, 0, 1 square 1, 2 square 4 and 3 square 9. So this is our answer. Okay, in the same way here, this one express set A. Next example, express set A. This one is given, numerical value is given. It means this is in roster form. Numerical value is given, it means roster form. Now we need to convert in builder form. Okay, so it's very easy. See this here. What we will do here, set A. Now see this, how to write property. Here if you observe this one, so you can say this one is here 2 is, we can write in this 1 square plus 1. With the help of property we will write here. So see this here, this one here what we are writing, 2 square plus 1. This one can be writing this 3 square plus 1, and this one we can write 4 square plus 1, and this one is 26 is 5 square plus 1. Now see this here. So what can we write? We can write in this way, x px. Okay, x equals to x such that px. This is the property. What we are writing here means x equals to n square plus 1. N square plus 1. N square plus 1. Why? If you put 1 here, so what you will get? 1 square plus 1. You will get 2. If you put 2 here, so 2 square plus 1. You will get 5. 3 square plus 1. 10. 4 square plus 1. 17. 5 square plus 1. 26. Okay. But actually it is starting from 1 and it is going up to 5 only. So we need to write condition also. Condition will be here, x less than equal to 5 and less than equal to 5 and greater than equal to 1. Okay, this condition is very important here. This condition is very important. Why? See this na, less than equal to, equal sign is there. If you put 1, so you will get this one, 2, 3, 4, 5, up to 5 it is going. So we write x is less than equal to 5 and greater than equal to 1. So this is our answer. Okay, so I hope you are getting this. Next example. Our next example is write the solution set of the equation x square plus x minus 2 equals to 0 in roster form. See this here, in roster form. Again, roster form means our answer will be in numerical values. Now see this here, x square plus x minus 2. Now see this. Factorize this. X square plus x minus 2 equals to 0. So we can write in this x square plus 2x minus x minus 2 equals to 0. And after that, if you factorize this, so you can write x plus 2 into x minus 1 equals to 0. Okay, now see this here. We know that product of two things is 0. It means this should be 0 and this should be 0. Okay, this should be 0 or this should be 0. So if you put this x plus 2 equals to 0, then you will get here x equals to minus 2. Here what you will get here? X minus 1 equals to 0, then you will get here x equals to 1. Okay, so finally you can write here set A I am going to consider. Anything you can consider, no issue. Set A. Okay, what is the elements of this? Minus 2 and 1. Minus 2 and 1. See this. This is in roster form. Numerical values we are getting here. Okay, and separated by comma and means enclosed by curly bracket. Now our next example is write the solution set of this x such that x is a positive integer. This is very important. What is positive integer? Positive integer means we know that I plus you can write I plus, or what is the meaning of this? 1, 2, 3, 4 and so on. This is called positive integer. And one condition is there which is very important here. X square less than 40 means a square of that number. Whatever is positive integer we will take, and square of that number should be less than 40. So it's very simple. See this here. Positive integer means it will start from 1. Okay, so I am taking here any set A I am taking. Okay, and we need to convert in roster form. So we know that already, means value of this will be obvious numerical values. Okay, and this is given property method, and we need to convert in roster. Now see this here. Set A equals to what we write? Positive integer. So 1 square, if you put here, it is starting from 1. If you put here 1, so a square of 1, which is less than 40. Yes, 1 is satisfying. Put 2 here, so 2 square 4 is less than 40. Yes, 2 is also possible. Put 3 here, positive 3 is less, 3 square 9 is less than 40. Yes. Okay, in the same way, if you put here 4, so 4 square 16 is less than 40. Yes. 5, put here 5 square 25 is less than 40. Yes. In the same way, put 6 here, so 6 square 36, which is less than 40. Yes. Now put 7. If you put 7, then this condition will not satisfy. Put 7 here, so you will get here 49 is less than 40. No, this condition is false. That's why we will not take 7. Up to 6 we will take. Okay, so this is in roster form. This is our answer. Okay, now see this here. Here what we are doing, this condition is given, means we need to take positive integer will start from 1, and okay, and this square of that positive number should be less than 40. So we will start from 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. 6 square means 36, which is less than 40. Yes, it is okay. But if you put 7 here, then it will not satisfying. So after 6 we will not take. Up to 6, from 1 to 6 we will take here. Okay, so 1, 2, 3, 4, these are the elements of this set A. This is in roster form. Okay, so this is. So our next heading is types of sets. So first type is null set, or you can say void set, or you can say empty set also. Empty set. Now see this here. What is called null set, void set or empty set? Means all names are same here. Null you can say void or you can say empty. So as the name suggests, empty means nothing, void means nothing, null means nothing. So a set containing, if a set containing no element, no elements called void set, or you can say null set, or you can say empty set. For example, it's very simple. See this name, null means nothing, void means nothing, or empty you can say nothing. Okay, so if a set containing no element is called void set. Okay, now see this here. For example, I am taking here set A. We need to find a set is there, set A is there. Okay, and we need to find set A in set A find real roots of equation x square plus x plus 1 equals to 0. See this here, set A is there, find real roots of the equation x square plus x plus 1. Now we know that this is a quadratic equation. Okay, we can compare with this one, ax square plus bx plus c equals to 0. If you compare the coefficients, so you will get here a equals to 1. Okay, after comparing the coefficients, you will get a equals to 1, b equals to 1 and c equals to 1. Now see this here, we know that for finding the real roots or imaginary in this way, we need to find first discriminant, d equals to b square minus 4ac. So b square minus 4ac, what is b here? 1 square minus 4a into c, means we are getting minus 3, and we can say here d equals to minus 3, which is less than 0. D is less than 0. When d less than 0 means no real roots, imaginary roots. Okay, you can say no real roots, or you can say imaginary roots. So what is the value of this? What is the value of this? Find real roots of this equation x square plus x plus 1. We need to find actually, we need to find a real, but what we are getting? Nothing, no real roots, means no solution. So we can say 5. You can say a equals to 5. Okay, and one more thing, this is denoted by null set is denoted by 5 or this empty curly bracket. Okay, so this is denoted by 5 means nothing, and this are means empty curly bracket means nothing. Okay, so a equals to 5. This is your answer. If I will take one more example here, next example if I am taking here, suppose set A is there. Okay, and here x, here n is there, and n belongs to natural number. N belongs to natural number condition is there, and n lies between 1 and 2. 1 and 2. Okay, so see this. What is the value? What is the? We need to convert in. So what is the solution? See this here. Set A is given. This is given in property method. So we need to convert in roster form. Okay, so n belongs to natural number. Natural means it will start from 1. Okay, and one more condition is there. Means this one condition. N belongs to 1 to 2. 1 to 2. So tell me there is any natural number which lies between 1 to 2. There is no natural number between 1 and 2. That's why solution of this is 5. Means no solution. No solution. This is your answer. Okay, what is the reason of this? Means n belongs to natural number and condition is given n lies between 1 and 2. It means there is no natural number between 1 and 2. So that's why solution this is does not exist. So we can say a equals to 5. Okay, now we are going to start singleton set. Now we are going to start singleton set. So as the name suggests, a singleton. Single means we know that singleton. Now see this here, singleton set. Second is singleton set. Okay, now see this. What is the meaning of this? It consisting only one set. Singleton. See this, na? It consisting single set. Only one set. Single set. Okay, called singleton set. It consisting single set means one set called singleton set. See this, for example, set A I am taking. Okay, and here n such that n belongs to natural number. Okay, and n lies between 1 to 3. N lies between 1 to 3. Okay, and n belongs to natural number, means it is starting from 1 and this n lies between 1 to 3. So what is the solution of this? So it's very simple. This is given in property method, or you can say set builder form. We need to convert in roster form. So it's very simple. See this here. Only one set is there. Tell me a number which is natural number. That should be natural number which is lies between 1 and 3. So 2 is a natural number which lies between 1 and 3. So here answer is 2. Okay, so this is our answer. See this. This is consisting only one set. This is consisting only one set. That's why it is called singleton set. Okay, now next heading is finite set. Next heading is finite set. Finite set. Set in which number of elements are finite, which can be counted, mean that should be countable. Okay, for example, I am taking here, see this here. What is called finite set? Set in which the number of elements are finite, which can be counted. Okay, now see this here. For example, I am taking here set, suppose set B is taking, okay, and inside this I am taking the elements 1, 2, 3, 4, 5 and 6. So these are the elements of set B. So total number of elements, how many elements are there? 6. So I can write here number of elements are 6, which is countable. We are counting easily. Okay, and this is denoted by in this way, and this is also called cardinal number. This is also called cardinal number, and it is denoted by n of a. What is the meaning of n of a? N of a means number of elements in set A. Okay, so how many number of elements here? So 6 elements. So we can write here number of elements and A equals to 6, means number of elements in set A equals to 6. This is called cardinal number. Okay, so and this is finite, so we are counting easily here. So our next heading is infinite set. So it will be just opposite of finite set. 4 is infinite set. Infinite set. Now see this here. What is called infinite set? Set in which the number of elements are infinite. Set in which number of elements are infinite, which cannot be counted, means which is not easy to count. Okay, now see this here. For example, I am taking here, what is infinite set? Set in which the number of elements are infinite, which cannot be counted. For example, see this here. I am taking suppose set C. Okay, inside this 1, 2, 3, 4 and so on. So see this here. How many elements? You can't say here only 4 elements. 1, 2, 3, 4 elements. No, actually it is going up to infinite. It is repeating. Okay, it is going up to infinite. So we can't count these elements. That's why we can say this is infinite set. Set in which the number of elements are infinite. See, this number of elements are infinite. Okay, which cannot be counted. Yes, we can't count here. That's why it is called infinite set. Next is equivalent set and equal set. Both are very important. Okay, equivalent set. Next is equivalent set. Fifth number, equivalent set. What is called equivalent set? See this. Let A and B are two sets. Let A and B are two sets are said to be equivalent, if n of A equals to n of B. This is very important. N of A equals n of B. What is called equivalent set? Let A and B are two sets are said to be equivalent, okay, if NA equals to NB. What is the meaning of NA? Number of elements. This is called cardinal number in set A, cardinal number in set B. Means number of elements in set A equals to number of elements in set B. Then we can say this is equivalent set. For example, I am taking here, suppose set A is there, okay, and SCHOL, okay, these are the elements of set A. Okay, and I am taking here set B, 1, 2, 3, 4 and 5. These are the elements of set B. These are the elements of set A, these are the elements of set B. Now see this here. Here we can write NA means cardinal number, or you can say number of elements in set A is 5. Here number NB means number of elements in set B is 5. So here we can say that NA equals to NB. So that's why we can say this is, see this, NA equals to 5, NB equals to 5, both are equal, so NA equals to NB, satisfying this condition. Okay, so we can say this is equivalent set. Okay, now after that equal set, that is very, very important, and then I will differentiate what is the difference between, what is the main difference between equivalent and equal set, how to identify easily. Now see this equal set. Equal set, 6 number, equal set, 6 number equal set. Let A and B are, let A and B are two equal sets, you can write A equals to B. Okay, let A and B are two equal set, A equals to B, then if, then every elements of, this is very, very important condition, every elements of set A belongs to set B, and every elements of set B, every element of set B belongs to set A. Now see this here, I am going to explain equal set. Let A and B are two equal set, A equals to B, then every elements, then this one, every element of set A belongs to set B, and every element of set B belongs to set A. So what is the meaning of this series, and what is the basic difference between equal set and equivalent sets? For example, I am taking here set A, I am taking here suppose SCHOL. Okay, now see this here. Second example I am taking here CHOLSCH. Now see this here. So number of elements here, number of elements, you can say NA equals number of elements in set A is 5. Here number of elements in set B equals 5. Okay, because we have already studied in roster form, it means we must not repeat any element in roster form. So see this is a roster form. So C is repeating 2 times, so we will count only 1 time. H is repeating 2 times, so we will write only 1 time. Only 1 time. So 1 and this one 1, 2, 3, 4, 5. So total number of elements in this set B is 5. Total number of elements in set A is 5. Now see this here. What is the condition? Let A and B are two equal sets. Set A and set B is same. See this set and this set both are equal or not? Yes, number of elements are same. And second thing is very important. Every elements of set A belongs to set B. All the elements of set A, every elements of set A is belonging to set B. Yes, all the elements is present in set B. Okay, and every elements of set B, all the elements of set B belonging to set A. Okay, then we can say this is equal set. So we can say this is equal set. So you can ask what is the difference between equal and equivalent set? So actually in equivalent set only number of elements should be same. but in equal set number of elements should be same, as well as every element of set A should be belonging to set B, and every element of set B belongs to set A. This is second condition is very, very important for equal set. Okay, so we can write one note here. Equal sets is always equivalent, but reverse may not true. How see this here? What is the meaning of this? Equal set is always equivalent, but reverse may not be true. Equal set, see this number of elements are same. Only in equivalent, only we need to we need to compare only number of elements. Number of elements is same, then we can say this is equivalent. So see this here, number of elements are same. So we can say this is equivalent. Okay, but equivalent set cannot be equal. Equal set can be equivalent set. So our first example is identify the types of the set. Okay, so first example is set A, x belongs to n, means natural number, and this x lies between 5 and 6. Okay, so we have to identify the types of sets. So this is null set, or you can say void set, or you can say empty set. Means set A equals to 5. Why is set A is null set, or you can solve, there is no solution. Actually x belongs to natural number, means it will start from 1, and x lies between 5 to 6. So there is no natural number, which lies between 5 and 6. So there is no solution. So A equals to 5, or you can say null set, or you can say empty or void set. Okay, so I hope you are getting this. What is the reason behind this? Means there is no natural number between 5 and 6. That's why this is null set. Next, this is finite set. Why? Number of elements are here, easily we can count. See this A, B, C, number of elements are finite, we can count easily. Means we can say NA, number of elements in set A equals to 3. See this, we are easily counting. So we can say this is finite set. Okay, next, B equals to set B equals to, given elements of this set B is 1, 2, 3 and so on. So this is infinite set. Why this is infinite set? Because number of elements in this set B are infinite. We can't count easily. See this here, 1, 2, 3, and it is going up to infinite. So this is infinite set. Okay, I hope you are getting these all the things. Next here, set A, these are the elements of this 1, 2, 6, 7. Okay, and B set B is given, these are the elements 6, 1, 2, 7, 7. So we need to identify here which type of set is there. So this is equal set. This is equal set. Why this is equal set? Because this set A equals to set B. Okay, set A equals to set B. Wow, see this here, 1, 2, 3, 4. So here what is the number of elements? NA 4. Here number of elements is NB equals to 4. You can say here 1, 2, 3, 4, 5 elements are there. No, only 4 elements is there. How? See this here, we have already studied in roster form. We must not repeat any element in roster form. Okay, so this is the roster form here. This 7 is repeating 2 times, but we will count only 1 time. So 7, 2, 1, 6, 4 elements. Number of elements in set B is 4. Number of elements in set A is 4. So NA equals to NB first thing, A equals to B, because this and this is same. And one more thing, what was the condition for equal set? You can say this can be equivalent. No, it cannot be equivalent. Why? Because in equivalent only number of elements should be same, but in equal set number of elements should be same, as well as every element of set B means belongs to set B, and every element of set B belongs to set A. So see this 1, 2 and 6 and 7, these all the elements are belonging to this set, and these all the elements are belonging to this set. That's why this is equal set. Okay, next, A equals to this one, A equals to 0. So it's very easy. This is singleton set. Why? It consisting only one element in the set. That's why it is called singleton set. Okay. Next, set B x such that, okay, x square minus 2 equals to 0 and x belongs to Q. What is the meaning of Q? Q means rational number. Okay. So we are going to find this. See this here. Actually, property is given. Okay. So first of all, we'll write in this x square minus 2 equals to 0. If you solve this one, you can say x equals to plus minus root 2, and we know that this root 2 is irrational number. This root 2 is irrational number. Okay, so this x is giving irrational number, but here condition is given x belongs to a rational number. So this is false or not? Yes, false, because it is given x belongs to rational number, but we are getting irrational number. So we can say there is no solution. X equals to 5. You can say x belongs to 5 means no solution. Or you can say, so which type of set is belonging? This is null set, or you can say void set, or you can say empty also. Okay. Next, see this here. Set C is given, and here some property is written. See this here, x such that x is an even prime number which is greater than 2. So what about this? It is also null set, or you can say void set, or you can say empty set. Why this is null set? Actually, there is no solution for this set also. Why? Because we know that 2 is the smallest even prime number. Okay, and here it is given x is an even prime number which is greater than 2. So there is no number which is even that should which is greater than equal to, and which is greater than equal to, there is no even prime number which is greater than 2. 2 is the only smallest even prime number. Okay, so we can say set C equals to 5, or it means this is null set. Okay, you can say void set or empty set also. So this set is null set. Why? There is no natural number between 5 and 6. That's why this is null set, means no solution. Here we are easily counting, so that's why we can say this finite number of elements are finite. Here number of elements are infinite. We are not able to count here. Next, here see this here, this set and this set both are same. All the elements of this set is belonging to this set. All the elements of this set is belonging to this set. That's why this is equal set. Okay, next, only one element in the set, singleton set. Here conditions are given, x belongs to rational number, it should be rational, but we are getting here irrational number. That's why this is null set. Next, x is an even prime number which is greater than 2. So we know that 2 is the only one which is a smallest even prime number. Okay, so there is no number which is even prime number which is greater than 2. Okay, so C equals to 5, or you can say null set. Okay, so I hope you are